Hi, Year 12 Maths General students. This is a lesson from Unit 4 of the Queensland General Maths syllabus, and today we're looking at solving problems using annuities formula in investment scenarios, and we're going to check our answers with the Excel TVM calculator. So the lesson objectives is to use annuities formula and apply it to investment scenarios. And then given that, we're going to solve a whole heap of problems involving annuities formula in investment scenarios. And like I said, check the answers with the TVM Excel calculator that we've used previously when checking answers to reducing balance loan problems. Okay, so often we're presented with problems where we have to calculate the payments involved. So they may be the deposit payments or withdrawal payments. In an investment situation, we might be asked to predict future balances or how much we should invest when we're trying to achieve investment goals in investment scenarios. So again, we're going to use the two different annuities formula that you find on your formula sheet. Remember, the one on the left is the future balance form, and the one on the right is the present balance form. So within those formula, the A always refers to the present or future balance we're talking about. M is always the payment value. In this case, it will be a deposit or withdrawal payment. I is your decimal interest rate. N is your number of compounding periods. Okay, so for this lesson, we're focusing on using this formula in investment scenarios. In a previous lesson, we looked at how we could use this formula in reducing balance loan scenarios. We mostly use the future balance form to solve annuities problems. So the future balance form can be used in investments to find things like if I'm looking at a deposit phase of a future investment balance, or if I want to know the regular payment value. If this starts from a zero investment, for example, in the beginning of a superannuation scenario, we can use this future balance form to find a future balance or a payment required to get to that future balance. Another way I can use the future balance form is if I'm looking at specifically a deposit phase of a future balance down the track after n compounding periods. I know there's a regular payment or deposit into the account represented by M, and I'm also given an investment amount to start with. So we call that the principal amount. So I use a combination of the compound interest formula that applies interest to the principal invested, and I add on the interest applied to the deposit payments that are made over time. And I may have to solve for the future balance, the principal amount, or the regular deposits made over time. There is another way I can use this future balance form as well in a withdrawal phase of a future balance. And this is exactly the same as a reducing balance loan form. You may recognize it from a previous lesson we've done. So this is when your investment account may go into withdrawal phase, and you want to find out what the future balance is after n compounding periods. The principal amount will be the amount you've saved to in that investment account. So you know that that continues to earn interest. And then you're subtracting the interest earned on the regular withdrawals you're making from that account. Okay, we can still use the present balance form in investment situations. A common one is when you're interested in finding an equivalent initial investment amount that you want to put in, that would be the same as making regular repayment values from a zero balance, which would be made over the same period of time to end up with the same final future balance. And we'll look at an example of that very shortly. Any of these formulas can be rearranged to find any of the variables within the formula. However, for general maths, you're only expected to do these types of calculations using technology. So when you're practicing textbook questions that ask you to use technology, you're welcome to use the free TVM spreadsheet that I put together. You'll find the download in the comments below this video. Okay, enough talk about the theory and formulas. Let's do some examples to get our heads around how we're going to use this formula. Make sure that you open this TVM calculator, because I'm going to use this in particular to check my answers. You may also like to visualize what's happening in these investment scenarios. So you could also use the investments payment schedule Excel calculator that I included in the last lesson we looked at. So in the first question, we have Katie. She's thinking about her financial future, as you all should be, and she has 30 years to save up for retirement. She can afford regular savings payments of $6,000 a quarter and's found an investment account that offers 3.2% per annum compounding quarterly. In part A, we need to determine how much she'd have in the account if she started with a $0 deposit after 30 years. Part B, we're going to calculate the equivalent amount of money she would have to invest now if she was to invest a lump sum to end up with the same future balance in part A without making any regular repayments. Part C, when she gets to retirement, we want to work out what are the maximum payments per quarter she should take out as income if she wants the investment to last her 20 years. Once I've worked through all of these questions, I'm going to make sure I check all my answers with that TVM Excel calculator, okay? And you could do it with the investment scheduling spreadsheet as well. All right, so like the good little math students we are, the first thing I'm going to do is annotate any important information in that question. So the $6,000 are going to be our regular quarterly deposits. Because we're talking about quarters, our K value is 4, time is 30 years, interest rate 3.2% per annum. We're starting with a $0 deposit, and we want to know our balance after the 30 years. So even when you annotate it, make sure you write down all your facts. This helps you process the information you have, and you should be able to easily identify what to do next. Because we're starting with a $0 balance, we're going to use our future balance form because we're trying to make a prediction on the balance she'll get to in 30 years' time, so 30 years into the future. So once you've reminded yourself by looking at the formula sheet which one to use, then simply substitute in your known values. Alright, so because I'm trying to find the balance after 30 years, that means my number of compounding periods is 120. So you just write that as a 120, so the balance after the 120th compounding period. Our deposits are $6,000 a quarter, and our interest rate after we convert it into the decimal form, considering the number of compounding periods, is 0.008. So once I put all that information in, that's what it looks like. We've spoken before about how terrible these calculations look when we're looking at using this formula in reducing balances. And I made the suggestion that you deal with a little bit at a time rather than putting it all in your calculator to help avoid mistakes. So the first thing I would evaluate is the inside brackets and work my way out. So just a quick reminder on how to put these into your calculator. Starting from this inside brackets, I'd simply find out what the 1 plus 008 is to the power of 120. So answer to the power of 120. Then I'm going to subtract 1. And then I would probably write down the simplified version of that top line. I would then worry about doing this next calculation. So the top divided by the bottom. So 1.0174-ish divided by 0.008 gives me 200.22 if I round it. Okay, and if I evaluate what that times the $6,000 regular deposits is, I get, after 30 years, an account balance of $1,201,304.82. All right, I want to check this using my TVM Excel calculator. So we'll pull that up. Okay, if you've saved it previously and it's got numbers in it, don't forget to press the refresh. Now it's really important that you consider the conditions when using this calculator. When we're talking about our repayments values that you put in will be positive when you're putting money into an account. When you're taking money out of an account regularly, then you'll put the value as negative. The other thing you need to be careful of when using this TVM calculator is in loan scenarios, the present and future values will be positive, and in investment scenarios, the values you enter in or calculate will be negative because we're looking at balances accrued. Okay, so let's put in the information from this scenario. We had 120 compounding periods, the 30 years. There were 4 compounds per year. The interest rate was 3.2%. Repayments, well, I was depositing $6,000, so that's going to be positive. The present value, so at the moment the balance is $0, and I'm interested in calculating the future value. So all you need to do is hit that calculate button, and it tells you that we'll have a future balance in the account of $1,201,304.82, which thankfully verifies what we found using the formula. Part B wants me to find how much would I have to invest now as a lump sum to end up with the same future balance if I didn't make regular repayments over the 30 years. So to find out how much that is, I'll use the present value form of the annuities formula. The way you can think of it is how much would I have to presently invest to end up with the same future value of $1,201,304.82. Okay, so what we're trying to solve for here is our balance, so our A0, which represents our principal. So what principal do we have to invest? That would be equivalent to making payments or deposits of $6,000 over that same 30-year period. So we do that by substituting all our known values into that present form of the equation. All right, so once I substitute all of these values in, so I've got my $6,000 regular repayments. I've popped in my interest, my 30 years worth of compounding periods. I would then again work on simplifying from the inside of the brackets outwards. Okay, so work out what 1.008 to the power of negative 120 is. From there, subtract that from 1. The answer to that, you would then divide by the 0.008, giving you 76.96. Then multiply that by your regular payments, and that would give you the equivalent amount of investing $461,731.35. So if you invested that now, you would end up with the $1,200,000 odd dollars without making any regular payments at all during that 30-year period. Let's quickly check this using the TVM calculator. Input that. We're not interested in future value at all. We just want to know what $6,000 of regular payments over 30 years would be equivalent to in a present value. Enter in your repayments, press calculate on your present value. So we've verified our present lump sum amount that we need to deposit now if it were to grow over 30 years without any regular repayments. Just note though, if you're unsure about this answer in an exam response, you could just simply use your compound interest formula to check it. So if you popped in the $461,731.35, told it to compound at that interest rate for 30 years, that will give you that future balance of $1,201,304.82. And again, you could verify this in your TVM calculator. You would simply just change your repayments to 0. You'd enter in that present value and hit calculate for your future value, which gives you the same amount. All right, part C is now she's gotten to retirement. We want to know what the maximum payments she's going to get per quarter if she was going to use that investment as income, and we want it to last her for 20 years. So because again we're predicting a future value, but this time we're looking at the withdrawal phase. So write down your facts. Now we need to predict that she's going to have a future balance of 0 because she's going to use up all her money. The principal we're using is what the investment has saved up to, and we're going to be solving for the payments she can afford to take out if she wants it to last for 20 years. All right, so after I substitute all of that in, I've put in my principal, I've added in my decimal interest rate. We want over 20 years, which is 80 quarters. Remember, I'm trying to solve for what payments she can take out. So solving for M is just going to involve your amazing solving equation skills. And at the moment, when you first put it in, the equation will look terrible. But you can simplify this by doing a little bit at a time. So remember, when I have brackets, work from the inside out. So simplifying this top part of your fraction, then dividing the top by the bottom, and you end up with one number. Same with your principal. Work out what this equates to. Then you can multiply that together. Again, you end up with one number. So now all you need to worry about is getting M by itself. So what I would do from there is I would move this to the other side of the equation by adding on the 111.46 by M. Once it's over here, all I need to do then is divide by the 111.46, and that will give me what my repayments will be per quarter. So it looks like a lot, but when you think about it, $20,391.79 per quarter will end up being about $1,700 a week. And considering all the bills and living expenses she'll need to account for, that's not too bad. All right, we have David, who's investing $40,000 into an account where he earns 4.2% per annum compounding monthly. He makes regular payments of $1,200. After 5 years, he wishes to use this total amount as extra income for the next 3 years. We have to calculate the monthly repayments he'll receive, and we'll check our answers with the TVM calculator. Okay, so there's two parts to this question. The first part is looking at a deposit phase given he has an initial investment amount. So that means that we have to use that future value deposit phase formula, which considers the amount he's investing as well as adding on the regular repayments he's depositing into that investment account. So once you've identified all the important facts, and of course written them down so you know what to use within your formula. We're looking at a decimal interest rate of 0.0035, taking in those 12 compounding periods a year. over 5 years of saving up, that means we're talking about 60 compounding periods. And then, like we saw in the previous question, it's just a matter of substituting in your values and evaluating all the different parts very carefully. All right, so when I initially substitute everything in, it looks very yuck and difficult to calculate. However, if I do a little bit at a time, you'll make it so much easier for yourself. So I'll evaluate these bracket parts first. So that gives me a single number to then apply to the 40,000. For the bigger brackets, again, working your way from inside, giving it to the power of 60, minusing 1 will give you 0.2332. If I then divide that by the decimal rate of interest, I end up again with a singular number. Okay, once I evaluate that, David should have a balance of $129,297.03 in his account after 5 years. Checking that with my TVM calculator, clear the last calculation we did. Okay, so number of compounding periods was 60. Compounds per year was monthly, so that's 12. It was 4.2% per annum. His regular deposits, so a positive value that he's putting into the account. The present value he's invested is $40,000, and make sure this is negative because it's an investment. And we want to know the future value, so we just hit calculate and we get the same value as we calculated using the formula. Just note, if you have any discrepancy or differences between the two values, you'll notice they're minor, and it's because with some of these decimals I've rounded them. So my formula calculated answer is using rounded values, where the TVM calculator uses exact values. The next part is considering the next stage of his investment, where he wants to use those savings as future income for the next 3 years. So we're swapping over to a withdrawal phase of the investment. So our principal amount is the amount he's saved to. Interest rate stays the same. This time we want 3 years, so our number of compounding periods is 36. We need to remember that he wants to use all of it up, so our future balance is going to be 0. Once I substitute all of those values in, again, it looks terrible, but you simplify it by evaluating little parts of it step by step. So remember, starting from the bracketed bits, working your way out, and then you'll eventually get to a form where our aim is to work out what payments he can withdraw to maintain that income for 3 years to get to a 0 balance. So to solve for M, at this stage here, all we need to do is shift this part to the other side of the equation by adding on 38.295 times M. Once I'm there, I simply divide by the 38.295, and that gives me the objective, which is to find the payments he could take out. And that works out to be $3,828.77 per month that he can take out, and that will last him 3 years. Let's check this on our TVM calculator. Change some information here. I'm interested in now 3 years worth, so 36 compounding periods. I'm trying to figure out my repayments, so I'll delete this information. Present value is how much is the investment worth when he wants to change over to the withdrawal period. So is it $129,297.03. Remember, you have to put that as a negative because it's an invested amount. The future value is going to be 0, and we want to calculate the repayments. So notice that the repayment value it gives us is also negative because it's telling us that that repayment is to be withdrawn from the account. Okay, again, the tiny discrepancy about between the cents there is due to the fact that I'm rounding these calculated values, which will not affect your marks at all when someone is marking a response in an exam. Okay, time to put your knowledge to the test. Try these 4 examples yourself. It should take a good half an hour to 40 minutes to get through. Okay, so read through the questions, make sure you annotate them, write down your important information, think carefully about what version of the annuities formula you're going to use, okay, and have a go. So press pause, try the 4 questions, unpause, and you can compare your answers to the solutions that I have. All right, let's look at question 3. Okay, so considering that we have an employee starting a new job, they're getting $800 a month, so their deposits into her superannuation account. The interest rate is 5.8% per annum compounded monthly. You've got to calculate the value of her super in 10 years' time. Now, this is one of those questions where we're going to assume there's a zero beginning balance because she's starting a new job and superannuation in a new account will start from a zero balance. So that means we're going to use our future balance form just by itself and substituting all of those values in. Hopefully you got around $129,690.17. So that will be the future balance of her superannuation in 10 years' time. Okay, for part B, we have an employee that was accruing money into his superannuation over 8 years. He checked his balance after the 8th year payment and it was at $65,000. Interest rate's 3.2%, compounding quarterly. We need to determine what quarterly payments the employer was making into the account. Now, the easiest way that you could do this question is pretend you're going back 8 years into the past. And from that point in time, can you consider the future value of the investment? And then from that, work out what payments you need to get to that future value of the investment. To me, that would be the easiest way to consider the question. You can use the present value formula to do it. However, that involves thinking about things in negatives, and we don't like negatives, so we want to keep everything positive. So if we want a future value of $65,000, substitute all my values in, given that I've got 32 compounding periods and a decimal interest rate of 0.008. Solving for M using your amazing rearranging equation skills. Hopefully you ended up with repayments of $1,790.40. So that means that every quarter the employer was making these payments into the account. Checking those values using the TVM. So if you did use that present value formula, that's fine. They're the values you would enter in to get your repayment. However, checking using the future value method, these are the values that I would have entered into the TVM calculator. Moving on to question 4. Here we're comparing two options for investing. So option 1, we've got 8% compounding quarterly, and our friend James can make regular payments of up to $600 per quarter. Option 2, same interest rate, except we're compounding monthly, and he can make regular payments of $250 per month. We need to give advice to James on which would be the better investment. Okay, because he's making a deposit as well as regular payments, I'm going to use that future value deposit phase formula. Hopefully in one way or another you compared the two options, so I just did it side by side. For option 1, he would eventually end up with a balance of $66,586.58. Option 2, he would end up with a balance of $70,538.38. So make sure you check your answers using the TVM calculator, and from those two potential investment options, you would definitely advise that James should take option 2 because he has more money accrued in the account after the 5 years. Question 5, we had Bodhi investing $360,000 into an annuity upon retiring that had an interest rate of 4.1% per annum, compounding monthly over 25 years. We needed to figure out how much income he would receive every month. So given that he has that principal of $360,000 and he's making withdrawal amounts, that means I need to use the future value withdrawal phase formula. Okay, so after you've calculated all the information that you need, so we've got a decimal interest rate of 0.003417, number of compounding periods is 300. He wants to use the investment up, so our future value is going to be $0. Pop everything in. Hopefully you very carefully simplify all those bracketed parts. And to solve for m, we're going to have to isolate it using our solving equation skills. Hopefully end up with an m value of $1,920.14. So that will be the monthly income he can give himself over 25 years. Check your values using the TVM calculator to show that you're on the right track. Okay, question 6 is a complex, unfamiliar question. So we've got Lily who's invests $4,000 into an account and she's saving up for a car that costs $16,000. The account she invests pays an interest of 4.3% per annum, compounding quarterly. She contributes deposits of $500 a quarter. 3 years into the investment, she's forced to withdraw $2,000. So she's taking out a lump sum. Determine how much she'll have to increase her payments to in order to make her goal of $16,000 in the same time frame. So this is going to be made up of parts. Firstly, we need to know how long it's going to take her to save up to the $16,000 initially. The second thing we're going to have to do is consider how much will she be left with after she withdraws that $2,000 lump sum amount, and then work out the payments she then needs to make to get to that future balance of $16,000. Okay, so looking at the first part of that question, working out how long it takes her to save up to that $16,000 initially, well, the easiest way to do that is to use recursion. You could use the future value deposit phase formula, but honestly it would take you forever to input everything to trial all the different n values. Using recursion, as we've seen in previous lessons, we can quickly set it up on our calculator to get to that particular balance, because we're trying to find out how long it takes to get to $16,000. Alright, so once you've figured out your rate of increase, so remember that's just 1 plus your decimal interest rate, using recursion on your calculator, you'll enter in your initial deposit of $4,000, then we multiply the answer by our R value, and the deposit phase, we're adding on $500. So then you'll just keep pressing equals while monitoring what the next consecutive balance is. So after 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So after 20 quarters, she exceeds that balance of $16,000. So 20 quarters is equivalent to 5 years. If you check that in your TVM calculator, you would be solving for n. You would pop in the fact that your you want the account to have $16,000 in it. You're putting in an initial value of $4,000 and you're depositing, so it's positive, payments of $500 a quarter. If you hit calculate, then it'll pop out 19.93 compounding periods. However, we'll just round that to the nearest quarter, which is 20. So then if you check that in the TVM calculator, this time you'll enter in 20 and you'll solve for the future value, and that will pop out the same value as what you got when you did recursion. Alright, so I've figured out how long it's going to take her to save up to this $16,000, so 5 years. Okay, so we need to know the balance after 3 years. Once we know the balance after 3 years, we can take out the $2,000 lump sum repayment. To do this, we'll use the future value deposit phase formula. Okay, so considering that she's got $4,000 over 12 compounding periods, so that's the 3 years of quarters. She's making deposits of $500. Once you solve for the balance, you'll see that in 3 years' time, her balance will be $10,917.63. From there, we need to subtract that lump sum of $2,000, which means that she'll have a balance of $8,917.63. And this means that given this balance, she now has 2 years left to get to that $16,000. Because there's 2 years left, that means it's 8 quarters. I want to now solve for the payments she needs to make to achieve that goal. So once I substitute everything in, I can then evaluate what I know, again being very careful to work out all the bracketed parts first to simplify it, and then isolate my m by solving the equation. And what you should end up with is new deposits of $761.95 will need to be made every quarter if she wants to meet that deadline of $16,044 within the 5 years of her whole savings goal. Okay, hopefully that's given you a bit of an understanding of how you can use those annuity formulas to help solve investment problems, because you will be expected to do this in exam questions. Simply a matter of reading the information carefully, especially the wording, in order to decide which version of the future balance form or the present balance form you could use to help solve the problem. Okay, good luck practicing more questions. Thanks, Year 12s.